Suppose a test for condition D is 99% sensitive and 95% specific. If a person tests positive for the condition, what actions should we take? Since the positive result could be a false positive, we need to consider the consequences of our actions. For example, if a person tests positive for COVID, actions they might take could include calling in sick to work, not visiting friends and family for a week. If they don't have COVID and took these actions for nothing, there's a slight disruption in their lifestyle. But what if the actions taken on the basis of a positive result are more impactful? For example, suppose that a test for drug use is 99% sensitive and 95% specific. We can set up our path diagram as before. A person might use drugs or not. Of those who use drugs, sensitivity tells us the test returns the correct value, positive 99% of the time. Of those who don't use drugs, the specificity tells us the test returns the correct result, negative 95% of the time. But to follow the path, we need to know how common drug use is among the tested population. So if we're doing random testing, then maybe 10% of those tested use drugs. As before, let's imagine testing 10,000 people. Of these, 10% of 10,000, that's 1,000, use drugs, and the remaining 9,000 do not. Of the 1,000 who use drugs and should test positive, 99% do test positive, and the remaining 10 persons test negative. Of the 1,000 who don't do drugs and who should test negative, 95% test negative, and the remaining test positive. From our table, we see there's 1,440 who tested positive, of whom 990 used drugs, and so the probability of the condition given that the test result is positive works out to be about 69%. Now, suppose this is a random drug test administered by an employer with a zero-tolerance policy. If you test positive, you are immediately fired. There are 1,440 who tested positive. If all of these people were terminated, the termination was justified in the sense that these people actually did the thing that caused them to be fired in 69% of the cases. Whether this action is justified in a moral or ethical sense transcends the mathematics, or does it? But this also means that the termination was not justified in 31% of the cases. And in particular, these people were fired for something they didn't do. The mathematics can't tell us whether this is a good thing or a bad thing. It can only tell us how often it occurs. The important thing is that a high sensitivity and high specificity do not guarantee the test results are reliable. We have to consider the prevalence in the population being tested. The lower the prevalence, the greater the likelihood a positive result is a false positive. Low prevalences typically occur in random testing or situations where everyone is tested. Now, this doesn't mean that testing is useless. In this case, the probability somebody had the condition is 10%, while the probability they had the condition given that they tested positive goes up to about 69%. So the positive test result did make us more confident the condition was present. However, we should be extremely careful about how we report this and be watchful of how it's presented by others. For example, given these probabilities, we can state our findings in several ways. First, there's a 69% chance a person who tests positive is a drug user. This is a simple statement of our probability. Or we might focus on the complementary probability. That's the probability they're not given that they tested positive. That's 31%. And say, even if a person has a positive test result, there's a 31% chance that this is a false positive. Or, since the quotient of our two probabilities is about 7, we could say that a positive test result makes it 7 times more likely that the person has the condition. All of these are true statements. But if you want to convince people to take action on the basis of the test, you focus on the multiplication factor. A person who tests positive is 7 times more likely to be a drug user. And if you want to argue against random testing, you focus on the false positives. A positive result for drug use is incorrect 31% of the time.